The diagrammatic representation of data. There are normally three forms in the way how you can present a data. What is the textual form of data? I'm talking about some data which is of high meaning to you. So quantitative data is one of the most impressive manner. We are going to use this word called as spatial classification. What are the major factors that you have written in the table? All of this are pictorial representations. Data is moving in a pattern. Good morning and welcome to the first session on Chapter 4, Presentation of Data. This is a very important chapter. Why? Because every one of us would like to present the data in the way it needs to be presented. It really needs to look good. It really needs to look approachable, accessible, and understandable in nature. So in statistics, we take time in doing the presentation of data. We use different methods, different standards to make the data meaningful, attractive, and also accessible in nature. So going forward in this chapter, let's have a quick look into the topics that are going to govern the presentation of data. So we have the introduction, we have the textual representation of data, quite an interesting topic for today. We also have the tabular presentation of data, that is also a very important part. Quantitative, temporal classification, spatial. You also have a little bit of tabulation of data and the parts of the table. That's a very important one. Why? Because before I proceed, this question will be a definite question in your board examinations, and this has to be a very integrated part of this lesson altogether. So moving forward, the diagrammatic representation of data, that's also going to form an important part, how we are going to put data in the form of various pictorial representations. You have the bar diagram, you have the pie diagram, histogram, frequency, Ogai, and the conclusion part for today. So not wasting much of your time, let's get forward onto the chapter. The introduction part. There are normally three forms in the way how you can present a data. You have a textual form, you have a tabular form, and you have a diagrammatic form. So three formats through which you will be able to present the data altogether. Now when you say the word textual form, then where does data come into? Now the data that is being written in the form of theory. So when you write it in sentences, we call it as textual form of data. The second one, tabular form of data. This is a very common pattern which all of us are accustomed, all of us are known to. Why? Because moment you see a tabular column with some rows and columns nicely put across, that is what represents to our mind, that is what pleases to our mind as data altogether. So tabular form of data is quite known factor altogether. And the last but not the least, you have the diagrammatic form of representation. That is the most attractive, appealing form of presenting the data altogether. So whenever you see those nice graphs, colored pie diagrams and charts, that is what going to really attract the eyes of the person who's going to look into it, and that's definitely going to be very meaningful because that's going to present a whole lot of data in a small and an easy manner altogether. So moving forward, what is the textual form of data? Let's have a quite close look into the way how it has been written. There is an example where we are going to talk about some data here. It says that in a statistics class of 40 students, 3 obtained a perfect score of 50, 16 students got a score of 40 and above, while 3 got 19 and below. So I'm going to talk about a data in a theoretical format. The entire data is presented to you like a mini story. So this is what we call it as the textual form of data representation altogether. All the variables, all the data is being written in the form of a paragraph here. You can see it here. You can see the numbers, they are written between the lines. So that's a textual form of data. I'm just going to put across all the numbers in the form of writing here. So that's how you will be able to see that as you read the paragraph, as you read the passage, you will be able to interpret and get some data values here. So that is where I really call a textual form of data. Now in this format, what is that we need to understand is that 90% of the time, any of us will not be able to collect the actual data or understand because we are mixing numbers with theory. So you might get confused in the long run trying to understand what did I really try to say. What was those numbers all about? So most of the time, textual form of data is good to read or probably good to know, but would be very difficult to represent and try to justify all across. So textual form of data is not much used in statistics altogether. Moving forward, we have the tabular form of data. This is the most fantastic thing that anybody would love to look into. Just have a look into the diagram itself. It talks about some location, some rural, urban. We are going to talk about skilled, unskilled. Now it's a very, very simple format. Now for example, if I'm just going to put some values here, let's say rural has got 55 and the unskilled, and then in the unskilled you have about 60. Urban skilled, you have 75, you have some 100. I'm just putting some random values here. So moment you look into the tabular column, you know that in the rural sector, there are 55 people who are skilled and 60 people who are unskilled. Simple as that. Those two numbers with the headings will make you understand that yes, I'm talking about something that is really valuable. I'm talking about some data which is of high meaning to you. Similarly, when I go to the urban sector, I'm just putting two random numbers, 75 skilled, 100 unskilled. So automatically you are able to understand that this is what I'm trying to represent, this is what I'm trying to convey together all in terms of this tabular column. So if you see here, the tabular presentation of data is the most simplistic manner, is the most easiest manner of putting data which can be understandable in nature altogether. Now moving forward, what is quantitative data? What do you mean by the word quantitative itself? Now look at the diagram one more time, because this is what is going to be quantitative interesting altogether. This is about the shelf, a bookcase, which is about 3 feet tall. It weighs about 100 pounds. It can have 15 books. It has 3 shelves. It has 2 cabinets, and it is worth of a sale of $1,500. All I have talked about the shelf in terms of numbers. I'm going to describe about its physical character in terms of height, in terms of weight, in terms of capacity, in terms of the physical arrangement, in terms of its movement, that is both width and length, and I'm also going to talk about its value, which is given as 1,500 here. This is what I call as quantitative data, which means to say that talk numbers and numbers only. I am not interested in theory. So if I'm going to be the person who's going to sell this bookcase to you, I'm just going to talk about numbers. I'm just going to tell you the brief description using the maximum number representation, and I'm going to tell you the value. If you are interested, please buy this bookcase from me at the price given, $1,500. So this is what we say by quantitative. When you talk numbers and numbers only, you're not using too much of words. You're using numbers to display, to describe, and to detail out your information very clearly to every single person who's looking at you, so that that person understands that he is trying to tell some meaning out of this numbers. So quantitative data is one of the most impressive manner of putting forward data in statistics to anybody across. So this is how we are looking into the quantitative factor. Now moving forward, a temporal classification conversion. This is what I typically mean as a temporal classification here. Somebody is speaking and it is getting converted as a text altogether. So what does it mean to us? Is it that we are doing data translation, or is it that we are trying to convert the data? Temporal classification is something where you are going to classify the data from one part to the other part altogether. So a person who is going to give you a verbal order, it is now going to get converted as a written order. So in temporal classification, you are going to classify the data using a particular manner, using a particular text conversion, you're using a particular methodology altogether. So the data that is going to be available to the person at the other end is understandable. So you're not just going to put the data as a number, as a theory, or as some symbols, but you're going to convert the data in the most approachable manner, in the most accessible manner, so that the person who's going to read that data understands it altogether. Moving forward. Now we have the spatial classification. We have spoken about this in the previous chapter also, but then again we need to understand why, because we are going to represent some place through the spatial classification. If you just look through this graph, you will be able to see that in this map we are trying to talk about some place, some location at some corner of the world. But then those colors that are being indicated on the map will try to tell you something, whether it's a high elevation, it's a low level elevation, does it have a water body, does it have some hills, mountain, plains, all those kind of geographical identification altogether. So any data that is going to be represented in the form of geographical location classification, where you're going to put in all the geographical dimensions about that place, we are going to use this word called as spatial classification. So that is why spatial classification matters a lot. Now many a times when you have been reading through maps, when you have been reading through the travel guides, tourism guides, you will see a lot of spatial classification. People try to represent a place very clearly by saying that yes, this is an elevated place, this is a beach, this has a water body, this has got so much of plain, this has got so much of land, this has got so much of winding roads. All those kind of spatial classification actually help the people to understand that place better. So that is why in statistics spatial classification has got a special place, and it is a very, very important format in the way you represent the data. Now moving forward, we are now going to talk about tabulation of data and the parts of a table. This question, before I start explaining you, itself is a very, very important question, as I told you in the introduction topics itself. Plus, what is more important than that is, this is where the most of the researchers, most of the important institutions in the world will represent data to you. So whenever you are doing a tabulation, whenever you are going to present a data, whenever you're going to present something to the world, you need to understand the parts of a table clearly, because this is how you will be representing the data altogether. Now let's have a quite close look into the tabulation of data and the parts of a table. Now, when you look into an ideal table, you will have different formats, starting with the title, then you go with the stubs, the row designation factor, the date, the column, the body of the table, footnotes, the source factor, and the table number. What are these things? Why are they first of all needed in a presentation altogether? Is it not enough that I just present a data in a tabular form, which can be understood by people because they know it? When they read that tabular form, when they look at it, they'll definitely get an idea. Why is that I have to take this extra step of putting things in the manner? Now, to give you a simple example, when you are presenting a data, what is more important is that the evidences, the genuinity of the data, the credibility of the data, that can be given only when you start giving out the parts of it in a clear manner. So you first start with the title of the table. Now let's say that we are going to keep the title as marks of a student. So this is going to be the title, or we can say academic performance. So that can be the title of the table altogether. Now next, you have different rows and stubs where now you will put the subjects, for example, English, Maths, Chemistry, Commerce, Economics, whatever is the subjects, you are going to put it and you're going to give a designation for that. You're going to give a titling for that altogether. Next, you have the date. When are you preparing this table? Now, you cannot say that the table was prepared 10 years back or 20 years back. The table has to be prepared on a particular date, and the date will have a meaning to it. So, you need to mention the date. So, if I'm preparing the table today, I will have put the date as 31 some date altogether. So, or if I am preparing the date in the month of March, so I will just put it as 31/3/2020 or whichever year I am preparing it. So the date matters a lot when you put in the table, because that tells the genuinity, the reasonedness of the table that has been prepared. The column headings and captions, what are those columns meaning to you? Why are you selecting those columns? What are the captions that are being given there? The captions will matter a lot, because for the person who's going to look into your data, he needs to understand each and every part of the table, and he needs to make an understanding in terms of a meaningful interpretation altogether. So the column heading or captions will matter a lot. Now we come to the major part that's called as the body of the table. That is what I call as the content factor. So when you are talking about the body of the table, you are talking about the contents. What are the major factors that you have written in the table? What is this table all about? It might be about some theoretical knowledge, or it might be about some statistical data, it might be about some academic report, it might be about some research report, but then that is the body of the table that talks about the content factor altogether. Now, the footnotes and references, what does they mean? Everything in this world comes out in a manner that people would have just done it by themselves. But actually, when people research it and find it out, you might see that the data is not true, or the data is not their own publication. So we need to take the help of references, and we need to put it in the columns down, saying that this data was taken from this publication or this particular journal or this particular paper altogether. The reason being is that that shows your genuineness in terms of presenting the data, that shows the credibility factor, and tomorrow that will also be a source of reference for you at any given point of time. So the footnotes will have the references, and you also make a small note, you also make a small titling head saying that this is what we mean about this data, because there might be certain rows or columns or certain data which is not understandable to everybody. So you just write it down stating that this is what we have tried to mean, or these are the columns, these are the rows, these are the factors, these are the measurements under which we have done. So all those footnotes and the explanation shall be given down. Next, we move to the source. From where is the data coming in? 90% of us are not primary researchers. 90% of us, we always believe that there is already data available. So let us take the data, let us make the best use of the data and move forward. So what big deal about it? But then the question that starts coming in is that tomorrow, if you are being caught for copying data from somebody else, it becomes a very big problem. So always you need to understand the source of the data gives the justification for presentation. So you need to give the source very clearly. If it is a secondary data taken out from some published journal, or from the internet, or from the social media, or from some published paper, from university journals, you need to give the source saying that this is where I have taken the data from. So the source of the data, from where it is originating altogether, that word has to be mentioned, that links have to be mentioned. Finally, the table number. Let's say that you are going to represent multiple data, table 1, 2, 3, like this. You have about some 10 or 20 odd tables. Let us give out a table number so that it is easy for the person who is going through your data. You can say refer table number 2, refer table number 3 or 4 or 5. So automatically a reference point is also built, and it will be easy for the person to go through the entire tabling altogether. So that is why the tabulation factor also matters when it comes to the table number. Moving forward. Diagrammatic representation of data. What are the diagrammatic representation? A bar diagram, a pie diagram, a histogram, a frequency polygon, and an Ogai. So we are going to look into each one of them individually. And now this is going to be the most interesting form of presenting data. Why? Because going forward, all of this are pictorial representation. So the picture is going to speak, the graph is going to speak, and not the words anymore. So that is why this form of representation is the most powerful way of representing a data in statistics. So moving forward, The bar diagram. Now if you just look at it, it's a very colorful picture with multiple colors trying to represent some number or some value. This might be 50, this might be 40, this might be a 20 or a 10 or some values like this. Bar diagram is an instance that is trying to represent an individual value altogether. You use a bar diagram to represent data when they are individual data and they do not relate to each other. So when you take individual random sample data, you can represent them by bar diagram in your graph sheets, in your Excel, so that they look attractive and they are also able to tell you out the meaning clearly at the given point of time. So that is why it matters a lot in terms of using the bar diagram. Next, pie diagram. This is a very common factor. You would have seen the pie diagram for many times, and now let's have a look into what does this pie diagram mean for us. Now when you look into the pie diagram, you will be able to see a split circle altogether, which is being decided upon the variables that are being given. So if you look here, we are trying to understand about what is your favorite fruit. So you would see that people have given their own research data. 30% of the people have supported for banana, 20% have supported on pineapple, 27% on grape, some data about a fruit. But the way it is represented, if you look at in a tabular form or in a theory form, this entire data would come for 2 or 3 pages. But then using a pie diagram, you can represent it in a less than a square space altogether. So now you see that the entire data is being represented in a nice circle, which is going to be divided into several sectors based on the opinions and the ideas that have been collected by the researcher. Now this form of representing is always done when you are going to talk about market share, when you're going to talk about opinions, when you're going to talk about leadership values, because these are the kinds where pie chart will actually give a lot of emphasis in terms of presenting the data in statistics. Moving forward. Histogram model. What is a histogram model? The word histogram itself tells us that data has been moving on a connecting factor altogether. So there is a movement of data over a particular range. There's a history behind the movement of data. Now if you see here, the frequency movement is quite closely interconnected. Each one of the data is keep on moving in a factor altogether, and the data is moving in a pattern. So the pattern movement of how data is moving, how data is trying to make an emphasis, how data is trying to create a model altogether comes here in histogram. So that's why we say histogram as a multi-model. It combines the various data, it connects the various data, and then it starts telling you where is the link altogether. So histogram is probably one of the most powerful tool when you are trying to represent a series of events which has been happening through. So if you see here, there are certain values which are quite closely linked. So automatically when you see the series, you will be able to understand the histogram very simply. To give you an example here, if you have been seeing cricket matches, they use a lot of histogram where they try to tell in which over maximum wickets were taken, in which over there were maximum runs given. All those factors are multi-model histogram. You can see that suppose in a particular over, let's say this was the over where there were 20 runs given. Suppose in some other over there were a lot of wickets. So let's say that there was a wicket loss in the first over. You will be able to understand on a continuous series that how the balls and the runs and the wickets are quite closely connected. So histogram is about the connection of data in a series given altogether. Now moving forward. Frequency polygon. Now you look at the frequency polygon, a very interesting form of data. You see here it starts moving at a particular length and a wavelength, and then it starts just sliding downward. What is it all about? Frequency means at a particular level, at a particular dimension altogether. So the way how the frequency polygon tries to talk about or tries to match the data altogether here is that it starts at a wavelength. It tells you at each and and every instance what has been a score or what has been the variable all about. So if you're looking at a test scores here, you will see that initially the test score started at somewhere around at 44.5 and it has kept on moving until it reached a particular frequency, and again it has started coming down. So you see that there is a wavelength, there is a matching that keeps on going, a pattern is being formed. So you can see the peak and you can also see the trough, the coming down of the data. So the frequency polygon gives you a series of matching that happens over a period of time. Moving forward, we're also going to talk about Ogai, which means to say that the less than and the more than factor. So you can see that what are all the factors that are combining here. Now you can see that there is a dotted line which takes about the less than. So how many people have scored less marks comparatively here. And you can see another Ogai which can see the more than score. So this is the combination of two factors. One on the greater side, one on the lesser side. Ogai is a combination that gives two different factors in one single graph. This is even more effective. Why? Because if you are doing a comparative analysis in statistics and you want to know exactly where people are trying to move on a particular range of data, Ogai would be the best part to understand. Ogai will give you the factors trying to understand the series movement over a period of time. So Ogai is also a very, very important and an effective tool for diagrammatic representation in statistics. Conclusion. So today we are able to understand that data can be represented in three formats. One is a textual form, the second one is a diagrammatic form, and the third one is the tabular form altogether. We are able to make an appropriate choice based on the type of data, based on the type and the need. We can draw a diagram, we can put it in textual, or we can represent it in the way we want. Now that makes the entire data meaningful, comprehensive and purposeful. These words are very, very important for us. That's why I'm going to underline it for you one more time. Meaningful, which means it adds meaning to the data that we have collected. It is comprehensive, it is integrated, it is kept as one single module which can add meaning, and it is purposeful. The data that we have collected should solve the purpose. It should not be something that you just wasted time on it or you just did it for the sake of doing it. It should be meaningful, it should be integrated, and it should solve the purpose. That is the most important part of presentation of data altogether. With this, we come to the conclusion of today's session. Thank you for joining me on this wonderful session today. I hope and believe that the session would have added some value to you in terms of statistics and economics. I also believe this session would be interesting, informative, and educative. Thank you for joining me today. Stay tuned, stay blessed, and stay enlightened forever.